Hi guys, I'm Zeri from Ace Academy again, and today I'm going to be solving February-March 2023 9709 variant 52, which is the Probability and Statistics paper 1. So let's begin. Question number 1. Each year, the total number of hours x of sunshine in Kintu is recorded during the month of June. The results for the last 60 years are summarized in the table. Draw a cumulative frequency graph to illustrate this data. Okay, so first we have to draw the midpoints. So endpoints actually. So x is less than 30, it's 0. X is less than 60, there are 4. X is less than 90, there are 12. X is less than 100, there are 26, which is 4 plus 8 plus 14. Afterwards, x is less than 140, it's 51. Then x is less than 180, it's 58. And finally, x is less than 240, which is 60. So we got the endpoints. The endpoints are gotten from the upper ends of each classes. And there is another class which is 0 is less than x is less than 30, which is this class. And the upper end is this one. But since there are 0 items in this class, it doesn't matter honestly. So let's draw it. On the y-axis, there will be cumulative frequency. Cumulative frequency. While on the x-axis, there will be the number of years. Number of years. Now let's draw the scales. So it's saying 30 till 240. Okay. So it's probably going to be 40, 80, 120, 160, 180, 200, and finally 240. Wait. 40, 80, 120, 160. Oh, I made a slight mistake. It's actually 200, 240, and finally 280. Okay, let's draw it. So these are the coordinates over here. 0, 30, 0, and 64, 90, 12, and so on and so on. So 30, 0. Let's draw 30, 0. So this must be 20, and this must be 30, which is the midpoint of 20 and 30. Okay. Oh, we forgot to draw the scales for cumulative frequency. All right. So it's going to be 10, 20, 30, 40, 50, 60. Okay. 60 is going to be more than enough for us. Okay. So 0, 30, and 0. This is this point. Then 60 and 4. 60 and 4, which is this point over here. Afterwards, 90 and 12. 90 mostly over here. This is 100. So 90 and 11, 12. 90 and 12. Then afterwards, 126. 126. 80, 90, 100, and 26. This is 126. Okay, then 140 and 51. 140 is going to be this, and 51. 51 is going to be over here. Then 180 and 58. 180 and 58. And finally, the endpoint, which is 240 and 60. 240 and 60. We got a nice S-shaped curve, and we need to now join all of the points together. It's pretty hard to do it on a device, so bear with me, guys. All right, drawn the first few points successfully. This was a bit wrong. Okay, no, still not right. Okay, then now it's gonna be, yeah, I managed to successfully draw it. So it's gonna look like this basically. Now moving on to the next question, which is use your graph to estimate the 70th percentile of this data. Okay, so 70% into 60, which is the total frequency. So 70% into 60 will give us 42. So on the y-axis, let's look for 42. So 42 would give us approximately 124, 128 years. So 42 would give us 128 years, and this is correct because your graph will come in a lot of, your graph will give a range of answers, and the accepted range for this question is 123 is less than x is less than 129. So if you have an answer that's within this range, you will get both marks for this question. So, number C. Calculate an estimate for the mean number of hours of sunshine in Kinto during June over the last 60 years. Okay, so then for this question, we're gonna have to copy this table, and I'm just gonna copy it this way. All right. Okay, we copied it. Now, in order to find mean, we need to find the midpoint for all of this data. So midpoint is 30 plus 60 by 2, which is 45, Afterwards, 60 plus 90 by 2, which is 75. 90 plus 110 by 2, which is 100. 110 plus 140 by 2, which is 125. And then 140 plus 180 by 2, which will give us 160. And finally, 180 plus 240 by 2, which is going to give us 210. All right. So mean, the formula for mean is summation of x into f by summation of n. Okay, summation of f. Okay, so let's do it. 45 into 4 plus 8 into 75 plus 14 into 100 plus 125 into 25 plus 160 into 7 plus 210 into 2 by divide by 60, which would give us 114.083, which is approximately equal to 114. Okay, this is the answer for 1C. Now let's move on to question number 2. Alicia has 4 coins. One of these coins is biased, so the probability of obtaining a head is 0.6. The other 3 coins are fair. Alicia throws the 4 coins at the same time. The random variable x denotes the number of heads obtained. So show that the probability of obtaining exactly one head is 0.225. Okay, so there are 4 coins. One of them is biased, and the other 3 are non-biased or unbiased. Okay, so there are two situations. Situation 1, the head that we will obtain is biased, while the 3 tails that we are going to get, since exactly one head needs to be obtained, are unbiased. All right, so let's find out the probability for this situation, which is 0.6, since the probability of obtaining a biased head is 0.6, followed by 0.5 into 0.5 into 0.5. So this is because in an unbiased coin, the probability of heads is 0.5 and the probability of tail is 0.5. They are equiprobable. So 0.6 into 0.5 cube. And here we don't do any selection because all the tails are identical. That's why no selection needs to be done. Okay, then there's situation 2. The head that we will obtain is unbiased, while 2 tails will be unbiased, and there will be 1 tail which is biased. So let's find out the probability for situation 2. For situation 2, we can select one coin from 3 coins, from 3 of the unbiased coins, from 3 unbiased coins. So basically it's 3 factorial. So the total probability for situation 2 is 3 factorial into 0.5, which is the probability of an unbiased tail, into 0.5 into 0.5 into 0.4. So the total probability is situation 1 plus situation 2, which is 0.6 into 0.5 cube, 0.6 into 0.5 cube, which will give us 0.075, and the situation 2 will give us 0.15. So 0.075 plus 0.15, which will give us the answer of 0.225. Proven. Okay, so moving on to part 2. Again, we have two situations here. Situation 1, which is one biased head, one unbiased head, and 2 unbiased tails. Okay, so let's calculate the probability for this situation. We can select 2 from 3 unbiased coins, so it's 3C2. So the probability for situation 1 is 0.6 into 0.5 into 3C2 into 0.5 square. And then there's another situation in which there will be 2 unbiased heads and then 1 biased tail and then 1 unbiased tail. So again, you can select 2 coins from 3 unbiased coins, so it's 3C2 into 0.5, which is the probability of an unbiased head, into 0.5 into 0.4, which is a probability of a biased tail, followed by 0.5, which is a probability of an unbiased tail. So adding the two situations together, situation 1 plus 2 will give us 0.375. So probability of x equals to 2 is 0.375. Now, for random variables, the summation of probability equals to 1. So, to find probability of x equals to 3, we have to subtract all of these from 1. So, 1 probability of x equals to 3 equals 1 minus 0.075, 1 minus 0.075 minus 0.375 minus 0.225 minus 0.05. So the answer will be 0.275. Part C. Given that e of x equals to 2.1, find the value of VAR of x. Okay, so the formula for e of x is summation of x into p, which is 2.1, but they ask for var of x, which is summation of x squared into p minus e of x whole square. Okay, so 0 square into 0.5, 0 square into 0.5 plus 1 square into 0.225, 1 square into 0.225 plus 2 square into 0.375, 2 square into 0.375 plus 3 square into 0.275 plus finally 4 square into 0.075 minus 2.1 whole square, and then you will get variance of x, which is 0.99. Question number 3. 80% of the residents of Kinwawa are in favor of a leisure center being built in the town. 20 residents of Kinwawa are chosen at random and asked in turn whether they are in favor of the leisure center. Find the probability that more than 17 of the residents are in favor of the leisure center. Okay, so this is a typical binomial distribution question. So x is a variable with a binomial distribution and there are 20 and the probability is 0.8, probability of success. So they're asking that more than 17, which is probability of x equals to 18 plus probability of x equals to 19 plus probability of x equals to 20. The formula of binomial distribution is NCR, probability of success to the power R, and probability minus probability of failure to the power N minus R. Alright, so let's do it. 20C18, 0.8 to the power 18 into 0.2 square plus 20C19, 0.18 to the power 19 followed by 0.2, 0.8, sorry, plus 20C20, 0.8 to the power 20, 0.2 to the power 0, which will give us 0.1369 plus 0.0576 plus 0.0115, and finally the answer will be 0.206. Alright, so question number B. Find the probability that the fifth person asked is the first person who is not in favor of the leisure center. So probability of not in favor is 1 minus 0.8 equals to 0.2. So this is a typical geometric progression question. So there will be 5 people, 1, 2, 3, 4, and 5. So first favor, 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 and then not favor. So this will be 0.8 to the power 4 into 0.2, which is 0.0819. Part C. Find the probability that the seventh person asked is the second person who is not in favor of the leisure center. Okay, so there are 7 people, 1, 2, 3, 4, 5, 6, 7, and the seventh person is not in favor, and the probability of that is 0.2. Then it talked about the fact that there was also one person in any of the 1 to 6 positions. So these all could be not in favor. So there are in total 6 positions. So 0.2 into 6 minus 1, 0.5 favorable positions, 0.8 to the power 5 into 6 into 0.2, which will give us 0.0786432. Again reiterating, there was another person who was not in favor in the position 1 to 6, and this could be any position from 1 to 6. And one person will not be in favor, followed by 5 persons who are in favor. So 0.2 into 0.8 to the power 5 into 6 into 0.2, which will give us 0.0786. Moving on to question number 4. The probability that it will rain on any given day is X. Okay, so let's start drawing a tree diagram over here. So rain and no rain. All right. If it's raining, the probability that Aaron wears a hat is 0.8. Okay. Hat, no hat, 0.8. Okay, X, and then 1 minus X, 0.8, and 1 minus 0.8, which is 0.2. And then if it's not raining, the probability that he wears a hat is 0.3. So not raining, hat, no hat. So 0.3, 0.7. Okay. Then it said whether it's raining or not, if Aaron wears a hat, the probability that he wears a scarf is 0.4. So scarf 0.4. No scarf is 0.6. No hat and scarf if he does not wear a hat, then he won't if he does not wear a hat, then the probability that he wears a scarf is 0.1, and the probability that he does not wear a scarf will then be 1 minus 0.1, which is 0.9. Okay, then hat again 0.4, no scarf 0.6, no hat it's 0.1, and hat and no hat scarf it's 0.9. Okay, the tree diagram is complete. The probability that on a randomly chosen day it's not raining, So not raining this one, and Aran is not wearing a hat nor a scarf. So overall, this entire section over here is 0.36. All right. So now we can calculate x. 1 minus x, 0.7, 0.9 equals to 0.36. So 1 minus x equals to 0.36 by 0.7 into 0.9, 4 by 7, minus x equals to minus 3 by 7. So x equals to 3 by 7 is the answer. All right. Question number 5. Marco has 4 boxes labeled K, L, M, and N. He places them in a straight line in the order K, L, M, N with K on the left. Marco also has 4 colored marbles. One is red, one is green, one is white, and one is yellow. He places a single marble in each box at random. Events A and B are defined as follows. A. The white marble is in either box L or box M. B. The red marble is to the left of both the green marble and the yellow marble. Alright, so there are basically 4 boxes K, L, M, N. Okay, and there are 4 marbles, which is red, green, white, and yellow. Alright, so let's look at probability A. Event A. The white marble is either in box L or M. Okay, so it's gonna be, there are 4 spaces for the four boxes. There are 4 boxes for the 4 marbles, and let's assume that the white marble is in L. So there are 3 other spaces for the 3 marbles, so they can be arranged in 3 into 2 into 1 or 3p3 ways. Now there is another way they could be arranged, which is if the white marble was in box M. Okay, the white marble is in box M, and then the 3 marbles can be arranged in 3p3 ways again. 3 into 2 into 1. 3p3 ways. So probability of event A is 3 factorial 3p3 plus 3p3 by 4 factorial. Why 4 factorial? Because there are 4 boxes and there are 4 marbles. So it's 4 factorial. So the answer is 3p3 in plus 3p3 by 4 factorial, which is gonna be 1 by 2. Alright. Now, there's the second one. The red marble is to the left of both the green marble and the yellow marble. Okay. K, L, M, N. The red marble is in K, let's assume that. And then the other marbles, especially the green marble and the yellow marble, could be in either of these 3 places. So this will be 3 into 2 into 1. So again, 3p3 ways. This is for event 1, event A. And then there's another way in which this could be arranged, KLMN, in which the red marble is in L, while the green marble and the yellow marble, they are in here. So the white marble would be here. Thus, they can be arranged in 2 into 2 ways. They can be arranged in 2 ways because the yellow and the green marbles, they can switch places. so that the yellow can be in M box and the green can be in box N. So for event B, the probability of getting event B is 3p3 plus 2 by 4 factorial, and 4 factorial is the total number of ways the 4 marbles can be arranged in the 4 boxes. So the probability is 1 by 3. Alright, and we have learned that in order to be independent, probability of A intersection B equals to probability of A into probability of B. Now we have to find probability of A intersection B. Probability of A intersection B. And for that, the condition will be that the white marble will be in either L or M and the red marble will be to the left. Alright. K, L, M, N. Alright. And it will be in K, let's assume that. And the white marble would be in here, for example, and then the other two marbles would be arranged in 2 into 1 ways. But it could also be that the white marble is in box M, while the red marble is still in box K. So this could still be arranged in yet 2 into 1 ways. So the probability of A intersection B would be 4 by 4 factorial, which is 1 by 6. Now, you could also ask me as to whether whether the red marble would be in L. And in order for that to happen, if it was in box L, then both the green marble and the yellow marble would be over here, and the white marble would have to be in box K, and this would not satisfy event A, because in this case the white marble is in box K instead of being in L or M, so this won't be a valid scenario. So the probability of A intersection B is 4 by 4 factorial by or which is 1 by 6. So we can see, and then let's calculate probability of A into probability of B, which is 1 by 3 into 1 by 2. 1 by 2 into 1 by 3, which is 1 by 6. Thus, probability of A intersection B equals to probability of A into probability of B, and hence the events are independent. Are independent. Alright, so question number 6. In a cycling event, the time taken to complete a course are modeled by a normal distribution with mean 62.3 minutes and standard deviation 8.4 minutes. Find the probability that a randomly chosen cyclist has a time less than 74 minutes. Okay, this is a typical normal distribution question. So x is a random variable with a normal distribution with a mean of 62.3 and standard deviation 8.4. So variance is 8.4 square. Okay. The probability of x is less than 74 is probability of z is less than 74 minus 62.3 by 84, which is probability of z is less than 1.393. So let's look at the probability. So let's look at the probability distribution table. So 1.393, 1.3, then 9, then 3. 0.9177 plus 5 by 10,000. 0.9177 plus 5 by 10,000, which will give us 0.9182, thus 0.918. Okay, so part B. Find the probability that 4 randomly chosen cyclists all have times between 50 and 74 minutes. So let's look at the diagram for this normal distribution over here. As we already discussed, the mean was 62.3. So 50 would be somewhere in the left, while 74 would be somewhere in the right. So we have to identify or calculate the probability of between t equals to 50 and t equals to 74. All right. Probability of 50 is less than t is less than 74 equals to probability of 50 minus 62.3 by 8.4 is less than z is less than 74 minus 62.3 by 8.4. Okay, so it will give us 1.464 minus z minus 1.393. We have already established that probability of z is less than 1.393 is 0.918. Okay, so probability, and we cannot find the value of negative z values. So to find the value of negative z, what we do is that we convert it to a positive z and change the sign so that this value is equal to 1 minus this value. So probability is z is less than 1.393 minus 1 minus probability of z is less than 1.464. So basically what we are doing over here is we are calculating the probability from here and then subtracting this part and then subtracting this part. Then we can get this part, which is the probability for time between t equals to 50 and t equals to 74 minutes. All right. So probability of z is less than 1.393 is phi equals to 0.9181 and 1.464. 1.46 and then 4, which is 0.9279 plus 6 by 10,000 minus 1 minus 0.9279 plus 6 by 10,000. Okay, so this will give us 0.918 9182 minus 1 plus 0.9285 0.9285, which is gonna give us the answer of 0.8467. Now this is probability for one person, but probability of 4 people having times within this time frame is 0.8467 to the power of 4, which is 0.514, and this is the answer for part B. Part C. In a different cycling event, the times can also be modeled by a normal distribution. 23% of the cyclists have times less than 36 minutes, and 10% of the cyclists have times greater than 54 minutes. All right, so this is again a normal distribution question, but we don't have the mu, which is the mean, and the sigma. square, which is the variance. So probability of x is less than 36 equals to probability of z is less than 36 minus mu by sigma, and which will give us an area of 0.23. All right, then we can't find probability is less than 0.5, so we have to convert this. Probability of x is greater than 36 equals to probability of z is greater than 36 minus mu by sigma equals to 1 minus 0.23, which is 0.77. Z is greater than 36 minus mu by sigma equals to 0.77. Now we have to identify the probability from the z value, which is 0.77, right? So 0.77, 0.77. This looks like something potentially correct. 0.73 plus 27, so 0.739. So 36 minus mu by sigma is minus 0.739. So why this is minus? So it has already shown us that this part will be 23%. So in order for x is less than 36 minutes to be 23%, this must be below the mean. So this is negative. Thus, this will be equation 1. Now, equation 2. Probability of x is greater than 54 equals to probability of z is greater than 54 minus mu by sigma, which is phi of 0.1 as already told in the question. Thus, we have to convert it again. Probability of x is less than 54 equals to probability of z is less than 54 minus mu by sigma equals to 0.9. Now we have to identify 0.9 from the probability distribution table, which is 0.8997, 1.28 plus 4. Okay, 0.8997 plus 4 by 10,000. 54 minus mu by sigma equals to 0.8997 plus 0.8997, which is 1.282. 1.282, and this z value of 1.282 will give us a value of 0.9. Okay, so this is equation number 2. Now equation 1 divided by equation 2, 36 minus mu by sigma by 54 minus mu by sigma equals to 0.739 by 1.282. All right, 36 minus mu by sigma into sigma by 54 minus mu equals to minus 0.739 by 1.282. Sigma, these standard deviations will cancel out. Then let's cross multiply. 46.152, we're basically cross multiplying this side and then this side. Okay, 46.152 minus 1.282 mu equals to minus 39.906 plus 0.739 mu. So 2.021 mu equals to 86.058. Thus mu equals to 42.6. Now 54 minus mu by sigma equals to 1.282. Thus 54 minus sigma is 1.282 sigma. Thus 54 minus 42.6 is 1.282 sigma. Thus sigma equals to 8.91. Mu equals to this and sigma equals to this. Question number 7. Find the number of different arrangements of the letters in the word delivered in which the three E's are together and the two D's are not next to each other. Okay, so let's assume these are the three E's which are together, then 3, 4, 5, 6, 7, and then the two D's will not be next to each other. So they will be in these spaces. 1, 2, 3, 4, 5, 6. So there are 6 spaces but only two D's to choose from. So 6p2 by 2 because the 2's are identical. And then there are 5 places. 1, 2, 3, 4, 5. So it's 5p5 into, you can arrange them in 3 factorials, but then again they are repeats. So 3 factorial by 3 factorial, which is 1. So the total number of ways is 1800. And then there is an alternative way. So the 3 E's are together, right? 3 E's are together, but there are 2 situations in which the 3 E's are together. 3 E's are together equals to 3 E's and 2 D's together plus 3 E's plus 2 D not together. Alright, so the question asked that 3 E's are together but the 2 D's are not together. So rearranging this, 3 E's together but 2 D's not together equals to 3 E's together minus 3 E's minus both 3 E's and 2 D's together. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 3 D's are together, and then there's 1, 2, 3, 4, 5, 6, 7. So 7 factorial. 7 factorial, 3 E's together equals to 7 factorial by 2 factorial. Why 2 factorial? Because the 2 D's are repeats over here. And then 3 factorial by 3 factorial. Because the E's can be arranged in 3 factorial ways, but then again there are 3 repeats. So this equals to 1. Now there is another case in which both 3's and D's are together. Both E's and D's are together, okay? So this is one unit. This is another unit. 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6. There are no repeats. So 6 factorial into 3 factorial by 3 factorial into 2 factorial by 2 factorial. So overall, the question will be 7 factorial by 2 factorial minus 6 factorial, which will give us the same answer of 1800. B. Find the probability that a randomly chosen arrangement of the 9 letters in the word delivered has exactly 4 letters between the two D's. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. D, then 4 spaces in front of them, there will be another D. This is one arrangement. Another one is 1, 2, 3, 4, 5, 6, 7, 8, 9. The D will be here, and 4 spaces in front of it, another D will be here. Another arrangement is 1, 2, 3, 4, 5, 6, 7, 8, 9. D here, and 4 spaces in front, D here. Finally, 1, 2, 3, 4, 5, 6, 7, 8, 9. D over here, and then D over here. So there are 4 types of these arrangements, and then in the remaining spaces you can write 7, 9 minus 2, 7, 6, 5, 4, 3, 2, 1. So it's basically 7 factorial by 3 factorial because the e's are repeated into 4 because there are 4 types of ways in which this could occur. And then to find the probability equals, we have to find the probability of this particular event happening, which is 7 factorial by 3 factorial into 4 divided by the total probability, which is 9 factorial because there are 9 letters, and then divided by 3 factorial into 2 factorial because there are 2 e's and there are 3 e's and 2 d's, and both of them are identical and repeated. That's why they are divided. So the answer will be 1 by 9. Finally, the last question for this variant. 5 letters are selected from the 9 letters in the word delivered. Find the number of different selections if the 5 letters include at least one D and one E. Okay, there will be a lot of different combinations, I guess. So there were already 2D and 3E. So other letters were 9 minus 5 equals to 4 other letters. Okay, so 1D, 1E, and then 3 other letters. Then there's 2D, 1E, 2 other letters, 2D, 2E, 2, and then 1 other letter, 3D, 1E, 1 other letter, 3D. Oh no, there are actually not 3D, so this won't be correct. Then there's 1D, 3E, and then 1 other letter. Finally, there's 2D and 3E and 0 other letters. And is there anything I missed? Yes, another one would be 1D and 2D while there are 2 other letters. This means other, by the way, not 0. 0 and then 1 other letter. So we don't really have to choose anything from D and E because they're all identical. So they're 1 into 4C3. 1 into 4C1. 1 into 4C1. Oh, this is 4C2. 1 into 4C1. This is exactly one arrangement. And then 1 into 4C1. So 4C3 will give us 4C3, 4, 4C2, 6, 4C1, 4, 4C1, 4, and then finally 1, and then 4. So total combinations is 4 plus 6 plus 4 plus 4 plus 1 plus 4. 4 into 4 plus 6 plus 1, which is, wait, 1, 2, 3, 4, 5, 6. 4 into 4. Oh no, there is actually 4C2 over here. 1, 2, 3. This is actually 4C. This is 2. So this is actually 4C2, 2. So 4C2 is 6. So in total, there are 4 plus 6 plus 4 plus 4 plus 1 plus 6, which is 25 combinations. And with that, we have finished an entire paper of 9709, probability and statistics paper. If you do like our video, feel free to subscribe, and if you have any queries or if you would like to obtain our notes on SoftQP, feel free to check out our Facebook and Instagram pages as well as our Discord server. Goodbye for now.